Hope you all are doing good. And it was a demand that was coming from most of our prestigious customers and as well as the new prospects that we should try to make a very specific tutorial video related to the pre-configuration, configuration, troubleshooting, steps related to WebdynSunPM, which is I'll say most of the globally it is being utilized and its most hot product at this moment. Due to its multitasking and multi-utilization possibilities, whereas it is an advanced data logger with these smart functionalities with multiple interfaces for Modbus, for TCP/IP on Modbus as well as on RTU. Then added interfaces. Secondly, it acts as a master-slave gateway, so also helps and acts as a WMS gateway for connection with the SCADA as well as onto cloud. And the third application is, even if you are not doing it for the local SCADA, but you can push the data to do different cloud servers altogether. And the fourth application, which in addition to all this is the power generation management, which is linked with DGPV synchronization or zero export power to grid, or both taken in consideration. This means this device is quite flexible, quite easy to utilize, provides you ample scope of its utilization depending from case to case, and thanks to its scriptability that it can be scripted, it can be written with a specific program based on to the site-to-site specific needs. This means you don't need to go for multi-different models or multi-different applications. So WebdynSunPM suits most of your heterogeneous applications as a single hardware. So moving on to this point, we start with the level 1. So we will part this video in 2 sections. First section will be related to the configuration and communication setup of WebdynSunPM. And in the second video, you will see more or less how the controlling, the power generation and management applications are being handled and managed. So keeping this video limited to the configuration part of it, we will start it from the step 1. So the step 1 is pre-configuration. So here we are not having the WebdynSunPM powered on or connected at this moment. That's why it's known as pre-configuration. So what we have to cross-check on the field, certainly our engineers' help can be taken to know these steps, and they anyways will share it to you over email, over phone call, and they will be always in touch with you as and when needed through email IDs that you will see in the display over here, and as well as the direct phone calls. So coming on to the step 1, which is pre-configuration, what you have to cross-check, firstly, if you have set up your solar installations, if you have set up the inverters, the meters, the sensors, or even transformer or numerical relay annunciators, whatever you want to communicate with. So firstly, what you have to do, check their communication in a third-party Modbus tool or Modbus application, either ModScan or Modbus Doctor, whatever you use. Majorly, it's ModScan that is being utilized. In some cases, it could be Modbus Doctor. So the purpose of this is to cross-check the communication, that whether the cabling that you have done from inverter to inverter and sensor and meters, either connecting them all together in a single chain or 2 or 3 different chains, are these chains communicating properly and bringing in the response from your slave devices as per the query being sent by the master, and the master here is WebdynSun or WebdynSunPM, for which we are talking about. So we have to cross-check that healthiness and the response. So this next step says check for the number of response versus poll. So this means polls are the queries that are being sent by the master, which is WebdynSun, WebdynSunPM, or the data logger. So the question or the query being sent to the slave device, and in response, what we have received from that device. As you can see in the screenshot below, the device ID 1. So the master, the ModScan software tool, has queried the device ID with number 1 to send the answer for the value which is available on the address 0001. So 0001 is generally mentioned here for the holding registers. Generally, if you will see, the holding registers starts with 40,001 as a sequence in the registers. So sometimes you can simply mention it as 01001 or something, or even 40,001. Both are similar if you are querying the holding registers. Now, based on to that, what you can do is just click on the connection and see what you are getting as a response. The length that we have taken in this example is 10, which means we are calling the addresses from 40,001 to 40,010. If you do the length of 5, you will be calling the response till 40,005 or 20 or so on. Sometimes this length is also restricted from field devices or field devices. So some may allow you to call 20 lengths altogether or 40 lengths. Some may restrict it to 5 lengths at a time to answer. So for example, as you can see here in the first screenshot, when the response has come up, the number of poles versus the response from the field device is matching. It's 76 poles versus 76 responses. This means your cabling, the communication from your field devices is healthy, as you can see in the text box mentioned over here, healthy communication. But if it is not true, means if your cable is not proper, sometimes it doesn't matter if you have used the best standard communication cable, still you may face unhealthy communication issues. If you are not laying the cable properly or not grounding its shield on one end, remember to ground the shield on one end, not on both the ends firstly. And if your cable is crossing and passing by the other current carrying cables of AC or DC nature, so if this is so, AC or DC current flow due to their magnetic flux interferences might create the issues in the response, because the data which is flowing in your communication cables is in bits and carries very low voltage and might get easily disturbed with any outer magnetic interference. That's why it's recommended as per the standards also to keep a sufficient distance between your communication cable and any other current carrying cables of minimum 300 mm or 500 mm if possible, if you have to lay down a communication cable in the same trench. And do remember to ground the one end of the shield always, so that any interference or any impact coming out of due to electromagnetic concerns should get to the ground immediately through the shield, and it should not impact much onto your real data carrying course. I hope till this point it's very clear why sometimes you see this issue of numbers of poles versus number of response not matching or having a big gap, as you can see here. If you are having a gap of, let's say, 1 or 2 responses, in response to 76 poles, if you are getting 74 or 73 or 75 responses, that can still be treated as healthy communications, but not below that. Now, coming back onto the first screenshot, if you will see now where the healthy communication is, you will see that the addresses have given some value. 40,001 is giving 57, 40,003 is giving 313. So these are your respective values from the response if you will see now, the responses are good, the answers are good based on to the queries from the devices. So if you are or your devices are falling as per the screenshot number 1, then you can proceed for the step 2. If the issues are unhealthy communication, like the screenshot number 2, you have to first correct it, recheck it until unless your poles and responses are matching and the answers to your queries from the addresses are not mentioned as Modbus message timeout, or until you start getting the correct values of your addresses as per the mapping provided by the manufacturer of that inverter meter sensor that you have configured or going to configure. Now, let's assume that your communication is healthy, your cables are good, your inverters, meter sensors are communicating well, and their device IDs, Modbus parametering is done perfectly fine. Now we can move on to the step 2, which is the configuration. So now, as you can see, the step 2 is the real configuration of WebdynSunPM. So as we have seen in the step 1, before configuring anything on the SunPM, we have to be sure that our field setup is proper and ready for the configuration, so that it saves the considerable time at your end as well as onto our end, and then we are a happy supplier and you are a happy customer. Moving on to WebdynSunPM configurations. So firstly, any new Webdyn hardware, being WebdynSun, SunPM, or Webdyn Modbus, they come up with a default IP address. That you have to connect the LAN 1, if it is WebdynSunPM, or the only LAN which is available on Sun or Modbus with your laptop. make sure that before opening up that page, your laptop is connected or configured in the same network, which means 192.168.1.***. So *** should be any number from 1 to 2455, which is not being taken any other gadget or device in the same network. Then only you will be able to open up the home page. Now let's assume that your laptop or the PC is having an ID of 192.168.1.13. Then you enter up this .12 in your browser and you will be able to see the first kind of screenshot wherein it asks for user and password. So as you can see, the user always, again, by default is user hi, as you can see in the bold letters over here, and which you have to put in here, and the password is hi, which you have to put in here. And then you will click on to login. Upon login, you will be redirected to the home page, wherein you will be getting the date, you will be getting the time, which is in UTC, which means it is a GMT time. So you have to add or subtract your time zone over this, from whichever country you are going to configure the logger. Then you will see the MAC ID, which is known as identifier, and it's basically linked with your site. The firmware version on which this device is working, if the latest versions are available, we'll recommend you to upgrade it or check with our support team to upgrade it. The kernel version is nothing related to you, which is anyways associated with firmware and the hardware of it. Then the serial number of the device and the last update, if it is there or not. Then Vivek will now show you in the real time the configuration page of it with a real device connected in our lab, that how this page will look like and how you can configure. So this is the home page as you are seeing in the WebdynSunPM. Here we have entered the ID, the URL of it, which is a by default. It can be changed depending on your network or on your will. But if you are changing this IP and making it saved in this controller, make sure that you write it clearly with the MAC ID, that for this MAC ID you have allocated altogether all new IP address for this. If you forget it, then the only way to retrieve the IP is to hard reset this device, which means it will remove out all your configurations and it will reach onto the default factory set IP instead. So always remember, if you are changing the IP, keep it safe, noted, and bind it with your MAC ID for the device. Now moving on to that, Vivek, please proceed on to step by step, that what could be these steps so that I can explain. So this is a devices page. Here you are going to configure all your field devices, be it Modbus, be it IO, be it any sort of other interface. So let's start with IO device. IO, here we have, let's say, IO, what is IO? Firstly, IO means either DI or analog input, dry input, or the output that we are going to control or manage. To show it as an example, we have utilized one analog sensor, which is a temperature sensor, and taking the temperature of the room right now. And it's an analog sensor with 4 to 20 milliamperes output. So the acquisition period, as you can see, the data that we should retrieve is mentioned in seconds. So you can do, this shows it very clearly that from 1 second to any time. So it shows for 1200 seconds. And 1200 seconds, now you can convert it into minute, divided by 60. You will be able to know that for nearly what time in minutes it is configured for. So what if you need to change this acquisition period, you can do so by changing this in seconds, equivalent to your minute calculation. Now, as you can see, how you can configure, you click onto sensor, you click onto AT, which is, or whatever name you want to give it. It is AT means ambient temperature, or if you want to write something else to identify it, you can write, and it will be shown it as a name over there. And this interface is, Vivek, I think we should not talk about Modbus. Let's talk about IO first, the configuration of IO. Yeah. So please show how the IOs are getting configured to the viewers. So here you will see, if you will scroll it down, after DIs, so there are 3 DIs available, so that's why you see 3 DI tables, rows to configure. If you're not configuring DI, leave it like this. Now we are configuring analog input, so we will check on the analog. And here, the good point is that we can select the type. If it is 4 to 20 or 0 to 10, 10 volts directly through this application. We don't need to do any changes of the jumper or shunt in case of WebdynSunPM, and it's that easy to configure through the program. So since it's a 420 milliamp sensor, we will click onto 420 milliamps. And it's an analog one. So since we are going to connect it on the analog one port of it, so we have to make sure. We will click onto 420 milliamps. Click onto action. So here we can also set if we want this parameter or this sensor to be ignored, which means we don't want to read it, or if we want the minimum, maximum, and average to be recorded, or if we want the instant value of the last second available in the data. So that is a choice. So currently we have clicked onto instant value. Click on the instant value Vivek. After that, we have to set the scale. That's depending on to the range of the sensor as well as onto the output. So 4 to 20 milliamps and the range if it is 200 degrees or if it is minus 20 to 80 degrees or 90 degrees. Based on to that, your scale and offset will change. This, our engineer and our team will guide you, and is also available in manual that how you can change or calculate out the scale and the offset value. So here for this sensor, the scale is, as you are seeing, the value 0.00625 and offset is minus 25. And there are no other sensors connected, so we'll proceed ahead with the configuration. आगे बढ़ते हैं विवेक. Save this configuration. So after saving, if we will move on to the IO page again and we'll click onto the sensor part, you will see the latest value now, which says now, which means it has answered just now with a value of 30.21, which is in degree centigrades basically, because we have already applied the offset value. So this says 30 degrees, 30.21 degrees to be precise as of now. Now if Vivek will refresh, you will see this value will remain more or less the same because it's connected in a room which has air conditioned, but the temperature is maintained nearly. So you can see whenever he is refreshing and it's connected in real time, it's giving you new values. So you can be sure that your sensor is connected, there is no lag in the data which it is showing, and it's giving you a correct value and there is no alarm. So we will now moving on to the Modbus section. As you can see that we have successfully configured the analog sensor now. So similarly, you can connect or you can configure the other 3 analog sensors if you have them connected, but make sure that on analog one, which sensor you are connecting, that is important. So that we should not have any confusion while configuring it over either your own web portal or third-party web portal or Webdyn's web portal. Now moving on to Modbus. Vivek, please click on to Modbus immediately. So moving on to the Modbus device configuration steps. Again, as you can see, it is another kind of sensor which is now with Modbus output. Same similar sensor which is temperature. Now here we have to set up the Modbus parametering and also the acquisition period. The timeout becomes essential, so we will keep it 0. As you can see in the system over here, timeout in milliseconds is set to 0. We will not change it until unless very necessary, and that for that if needed, you can cross-check with the Webdyn support. Can you please scroll down the screen, Vivek? So here, as you will see, we have now the Modbus device connected, and we have we should start with the configuration because this is the end result. Vivek. Let's move on to the configuration page of the Modbus. So we'll click on the device detect. As you can see, we will feed in the name. We will move on to the address mapping of it, which you can see Webdyn ABB. So it's for the ABB sort of inverter. Similarly, there are different definition files which Webdyn engineers will write, or they will have in their library. You can select depending on to the inverter or meter or sensor, and based on to that, the further configurations will start. So there is also a possibility of detect device. So this configuration is quite simple. It helps you to automatically detect the devices connected in the chain if they are properly communicating as per the step 1 of pre-configuration. Let's move further, Vivek, immediately. So we'll click on to serial 1 because for the RS485 or Modbus communication, there are 3 serial interfaces available. So we will first configure serial 1, then similarly serial 2 and serial 3. We need to know that on serial 1, what is the mode? Is it 2-wire or is it 4-wire? Generally in solar, we see most of the devices are 2-wire, which is in other terms known as half duplex as well. what is the baud rate of the devices connected in serial 1, what we want to configure. So we can set it from 9600 to click on the cursor of the baud rate Vivek to show what is the maximum value that we can go. So as you can see, we can go to the 4,60,800 baud rate value if your field device is connected in the chain supports. But please remember, and you might be knowing it very well, that if the length of your communication cable is increasing, we have to keep the baud rate to the lowest possible. If the length or the distance is minimum, it's always recommended to go for the highest level of the baud rates, if possible, so that the communication is faster, is clean and clear. So let's say it is at 9600 because most of the Modbus devices comes with a default baud rate of 9600. So we will let it like this. Database you can set 7 or 8. Similarly, and then the parity, again, depending on to the field devices configuration, if they are set to parity none or odd or even. And then the stop bits. So these are the 4 important parametering that you have to do depending on to the field device communications: baud rate, data bit, parity, and stop bit. Now, nothing else you have to do if it is a serial or RS485 device. We'll move on to serial 2 and serial 3 subsequently, and then you can change. The good thing is that for serial 2, serial 3, you can also set the independent baud rates. For example, if serial 1, you have connected the devices with baud rate 9600. On serial 2, you could connect the devices with different baud rates, parity, and stop bit, data bit also. Similarly on serial 3. So all the 3 ports are totally independent of each other, and you have the flexibility to connect different devices, communicating over different baud rates on different ports. And you can even set your own time for each device, a different data acquisition period. Moving further, you have the modem configuration page where you will now fix in the SIM card. So if you are using, for example, an Airtel SIM, so the APN, default APN generally for Airtel SIMs in India, for example, is airtelgprs.com. Similarly, for any other network provider belonging to any other country, the APNs are easily available, which you can either Google or can check with your network service provider for that particular SIM card. Having said that, you can also use the IoT specific SIM cards, and you can always check for the APN related to that IoT SIM to feed in. Once you will feed it in, you will click onto that. You will get to know about the SIM cards specification or the connectivity. You see the model firmware IMEI number of the modem, which is utilizing the SIM card. Then RSSI is the signal strength of the GSM communication. Then the calling rate, and then the dBm. dBm should generally be less than 65 in minus for a healthy communication. If it is going beyond 65 in minus, this means your network for GPRS or Edge or LTE connectivity is really, really weaker. And you might not be able to get the data in real time, what you have set. The IP address of this network provider and all this relative information you are able to see, and the network type which it is showing as 4G for the moment on which it is connected. Move further, Vivek. So then we are going to configure the FTP or SFTP or any kind of server where we would like our data files to push. So we can configure FTP or SFTP or WebDev over HTTP. So WebDev over HTTP is meant only for some crucial alerts to be shown or highlighted over the FTP or HTTP, pardon me. Or you can also configure it for MQTT as well. Now let's assume we are going to configure it simply over FTP. So click onto FTP. And the interface that we are going to utilize, is it through Ethernet or through SIM card as we have done it for modem? Change the interface, Vivek, click onto the interface. So since we have done the configuration for modem, we will do it modem. Click on the modem. Now set the FTP address of your FTP server, then the login password, and then the further things. And then move on to the configuration directory pages. You have to set the directories like this: /config for configuration, /data, /cmd. All these informations are available in the manual. So immediately you can check and make a slash. After that, enable data file header option. That's important because whenever you are getting a data file, the header will be available showing 1, 2, 3, 4, and under that header, the values. Move further, Vivek. You have to always click on that green tick and move ahead after that. And you are going to schedule this operation of data acquisition and connection to your server every day. So you're not going to set it for a particular duration. If you are going to set it for a particular duration, you can also do so. In the mode, we have set it for every day because we want this operation, this data to be available on the server in the set parametering every time in a count or in an interval as mentioned. So this is totally programmable that you can change. Move ahead, Vivek. Scripts we will talk about in the next video, but here you can put in the scripts are more or less utilizable to utilize its entire controller functionality for DGPV, zero export to grid management, battery management, and all such stuffs. Update helps you to update the firmware version if it is available or it is being recommended by Webdyn support team to you to update. Now we will move on to the common slide again. So the step 2, which is WebdynSunPM configuration, is done. Now we'll move on to step 3 because there could be some issues or that you could be still facing after the completion of step 2. Now the step 3, which says, okay, if you are able to configure the modem correctly, your field devices correctly, and they are showing correct values on the Modbus tester in the configuration. So, but still the data is not getting pushed onto the server. So what you have to do firstly is always observe immediately the LED status. What kind of LED color is it, under what name, and what is their status. So the chart here, the screenshot, as you can see, explains you about the specific LED which is under WAN, wireless area network. So if it is green and if it is flashing normally indicates, so you will have the green and the normal indication which says it's a modem signal level is good. So you see X slow flashes followed by a 1 second pause, it's okay. But if it is off, it's no connection attempts. If it is green and fast flashing, this means that FTP connection is in progress. It is trying to connect. If it is orange or amber color and flashing very slowly, this means this NTP synchronization. So NTP is network time protocol, from where it takes the real time from the network to stamp the data files. There is a problem and it's not able to connect for the NTP. So either your NTP server is having a problem, so you have to configure another NTP server, or the network is not strong enough to make a connection with NTP. And if it is red and slow flashing, this means your FTP connection is having a problem and in no ways it is able to connect to the FTP server. And if it is fast flashing in red, so problem attaching to the cell network or unstable reception, which means again the network problem. So red is very clear that it's a network problem. You have to check your network, either try to replace your SIM card with of another network which is workable or most likely available in that particular location or the point where this device is installed. Or if it is on Ethernet, make sure that the necessary available points are there, which means you are allowed for FTP progress, you are allowed by the network provider for NTP progress, and you are allowed for the IP that you are using in that network for this device. It is not blocked. If once you will correct this, automatically the LED indication will switch on to green, as you can see in the first step for the connectivity. So this is first you have to look at immediately what is the LED status. If it is red, take the immediate corrective action. This will save a lot of considerable time of the engineers on site. If it is green or if it is orange or if it is something else and it is still having a problem, then you may check or get in touch immediately with Webdyn support, either through call or through the email ID, which is shown over here, support-india@webdyn.com. So that's immediate troubleshooting step, because this is the general concerns that sometimes comes up if your network is not strong enough to push the data. Now let's assume from the step 2 everything was clear. So then we will jump on to step 4. We don't need to move into troubleshooting because there is no trouble anymore. Step 4, we will see that this is how your general server will look like if we are opening it through an app or some sort of software applications which are free to download anyway. So we are using here the FileZilla client. With that, what you have to do is you have to put the necessary credentials of your FTP or SFTP server, like the host or the URL number or the ID, username, password, and port number on which it was connected. Quick connect, and then you will be able to see if it is successful. If your server is having no problem, the status will be successful, and then you will see the kind of files as you are seeing on the screenshot at the right side of the screen, that which shows the zip files dropping in at the regular intervals, and these regular intervals are basically the interval that you have set. For example, in this case scenario, it is set that at every 10 minutes, a new data file should arrive with the new data set. So here you will see that, for example, the first file with the stamping, which it shows as a MAC ID, where you see WPM 0116D9, followed by underscore, and then the type of the file, if it is Modbus or if it is IO or if it is analog input. and then followed by the date stamp, which says 24/11/04, which means 24th April, and then or date and month setting, and then the time frame, which is 17:40:00, which means 5:40 in the evening as per the GMT time or UTC time. So then you have to add up your country specific time over that. So if you will see on the last column of it, which is last modified, you will see the data that has come up over here as per the Indian time zone was on 4th of 11th, means 11th of April in 2024 at 20. So with the date and timestamp, as you have seen, this is the raw data file that comes in, and with the last modified, which is a computer or the local system machine time, as you can see, the local time is 23:10, which means it is at night of 11th April on 2024. So this is how, because our Indian time is plus 5:30 over the GMT time. So this is how you can identify. Now, once you will unzip this file to open, and you will open up, it will be a CSV, which is basically a comma separated value files, which is openable in Excel, and you can convert it in a table form. If you will see in the next slide, this is how your file will look like. Can we move on to next page, next slide, Vivek? In this, you will see the device index, means the number of devices that are there, and the device ID, which is 7, with what kind of device is it, its name, or the definition file name, what you have configured it initially, which is Modbus sensor, so I to identify that it's a sensor, and the respective value under the header. So if you will see, there are headers. In the same row where 7 is written as a Modbus ID, you will see 1, 2, 3, 4, 5, 6, 7. So these are the headers in the increasing order to the number of parameters that you are reading. And under that, there are values, let's say of the value which was read at 17:35 and then 17:40 GMT time. So since here you will see that the data is being read in those time minutes frame at 5 minutes interval. So we are reading the data, in this case, from the field at every 5 minutes, keeping it, and then sending a common file every 10 minutes. So every 10-minute file will have the data, 2 data points of 5 minutes gap. So here you have the data file available, the data available of 17:35 and 17:40 with a certain value, which is mentioned under header number 3. And header number 3 basically is ambient temperature. How we know that it is an ambient temperature? This can be cross-checked from the definition file, which is also available on the same server under the definition. Here you see, which is on the encircled part, where header number 3 on the left, and then you see ambient written, which means it's an ambient temperature value. So it should come up under the header number 3, which is coming as 265. We have to apply a multiplication factor because it's a raw value. So the multiplication factor could be multiplied by 0.1. And this might vary from sensor to sensor, manufacturer's mapping provided for that. So if you will multiply it by 0.1, the temperature will become 26.5. So this means it will be an actual value. This change of or multiplication factor corrections are always done on the web portal levels based on what is provided, because the raw value, purpose of the raw value is to provide you the unaltered, untampered direct data that is being received from the connected devices to remain and to maintain the authenticity of the data. So that's all about the configuration. That's all about the troubleshooting part. And that's all about how you can do the configurations. If you are struck at any level related to the configuration of the devices, you have seen the email ID. Again, I will mention it here. As you can see, it's support-india@webdyn.com, on which you can immediately place your request when maybe a couple of days before, when you are actually preparing for on-site configuration. The team will share you some safety guidelines. The team will share you some checklists to follow, the tools that you have to carry.
So that's all. Thanks a lot to all of you for having this patience. Still, if you have any query, any concerns, please feel free to write us. Thank you very much, and we'll see you in next video.